Hello everyone. The other two questions that are going to be in the Show Your Work will be coming from that are going to be similar to question 38 from the review for test 2. It is an optional review because it has a lot of questions, but specifically question 38 is going to help you see the other two questions that are going to be the type that will be on the test. So we'll read it. In a recent year, the scores for reading portion of a test were normally distributed. Again, as soon as you see that, you should be inspired to draw the normal curve. Although that curve will be provided to you on the test, so you will see those questions that will have the normal curve there. So you continue reading, and it says with a mean of 2.2. So the mean, that is called mu, is 21.2, and the standard deviation is 5.3. So the mean is the highest point of that normal curve. So you identify the mean on the curve. You do not have to identify the standard deviation. So we're going to answer 4 questions that are going to use this information for the normal curve. So part A. Find the probability that the randomly selected high school student who took the reading portion of the test has a score that is less than 18. So X is the score that is, you're going to treat it as X equals 18 for calculation purposes to find the Z score. And since we are not provided with a sample size, that means we're not working with a sampling distribution. So the Z score is equal to X minus the population mean divided by the standard deviation. So, and the question here is, what is the probability of the score being less than 18? So we are going to standardize this 18 score by using the formula Z less than. So we take 18, you subtract the mean, and divide it by the standard deviation of 5.3. That will give you the Z score. So we enter that in the calculator. I have the Dora de calculadora here. So this is going to be in parentheses 18 minus 21.2, close the parentheses, divided by 5.3. Since I only have one number in the denominator, it is really optional to enter that part in parentheses. All you have to do, if you had more than that, like when we're dividing by the square root of the sample size, then you should definitely use parentheses. But for now, I don't. So you press enter, and the Z score will always be 2 decimal places. So this is going to be negative 0.60, negative 0.60. The 0 is followed by a 3, so we're not rounding up, it stays 0. So I will also be demonstrating how to use a calculator. So it's going to be second vars and option 2. So here, before we proceed, if we show that in the calculator, it's 18 here, and the question is, what is the probability of being less than 18? So this is going to be the work for part A. So less than 18, we're asking you for the area to the left. So here it is implied that it's going to continue all the way to something negative. So this right here will be considered your lower bound. And your upper bound is going to be, so in terms of the Z score, your lower bound is going to be negative 100, and your upper bound is negative, the Z score, that is negative 0.60. So this is the lower, and this is the upper bound. So in this calculator, my lower will be the negative 100, and my upper will be negative 0.60. I wrote 60, but it's negative 0.60 right here. And then you just press enter in this calculator, and this gives me the the probability is 0.2743 because the 2 is followed by a 5. So this probability, and this will come from the table, 0.2743. That is the answer for the probability. As simple as that. So now we're going to continue with part B. Move this up. So part B is asking for find the probability that a randomly selected high school student who took the reading portion of the test has a score that is between 13.5 and 28.9. So we should draw another picture. And the mean is the same. It's the same exercise. It's just a different part. So the next one is between 13.5. So that will be to the left of 21.2. And between 13.5 and 28.9. So here, 28.9. So keyword here is between. So here, this is between. So these are X scores. So now we're going to convert those to z-scores in order to be able to get the probability. So we have to find the z-score for 13.5 and the z-score for 28.9. So when we express this, is the probability of the scores to be between 13.5 and 28.9. So we have two conversions to make. One is going to be 13.5. The mean stays the same, 21.2 over the standard deviation is the same for all of the parts. So then this one is 28.9 minus 21.2 over the standard deviation of 5.3. So we're going to treat this as the X scores for this question. So we're going to enter those in the calculator, get the Z scores. And again, I'm going to demonstrate using the calculator to get the answer. So you turn DORA on, and then we have 13.5 minus 21.2. Another technique is that you just press enter after that, and then divide by 5.3, the standard deviation. And this gives me a z-score, always 2 decimal places, of negative 1.45. And then the second part, 28.9 minus 21.2, enter, divided by the square root of 5.3. Divided by 5.3. There's no square roots on this one. Delete that. Enter is 1.45. So what that means is that the z-score for 13.5 is negative 1.45. The z-score for 28.9 is 1.45. So in your calculator, to use it all with your calculator, we're going to go second vars, option 2. And this right here is going to be considered your lower. And this right here is going to be considered your upper. So we're going to enter negative, the negative in parentheses, 1.45. Enter. The next one is positive 1.45. After that, continue entering. Again, you can use your calculator, but DORA again is programmed with all the z-score tables. The answers will be up to 4 decimal places. So that is your final answer. Remember that you're going to be provided with the steps on how to use the calculator on the test, but you need to make sure that you practice on your own. So now we're going to go for part C. Part C is asking for find the probability that is randomly, so let me show the part. So we did part A, part B. So part C. Find the probability that a randomly selected high school student who took the reading portion of the test has a score that is more than 32.3. So we should draw another picture because this is a different exercise. Again, on the test, they will be there. The sample mean remains the same for all the parts. And again, part C is asking for more than 32.3. 32.3. More than, that means that it is to the right. You will continue to use the same mean, 21.2, standard deviation 5.3. And now these are X scores, or the students' scores, that we need to convert to Z scores so that we can standardize them and use the Z-score tables or use the calculator. So the probability of the score being greater than 32.3 is equal to the probability of the Z-score being greater than, so the Z-score is 32.3. You subtract the mean of 21.2 and divide by the standard deviation of 5.3. So we'll enter that in the calculator. 32.3 minus 21.2, enter, divided by 5.3. So that gives me 2.09. Again, the Z-score, you round it to 2 decimal places, 2.09. Since it is greater than, if you were to use the Z-score tables, you have to do 1 minus the probability of being less. But I am using the calculator here. So I'm going to go second vars, option 2. And in here, if you look at the drawing, this 32.3, that becomes the Z-score of 2.9. So this becomes your lower, and then the 100, because the area is heading towards infinite number of numbers. So therefore, we're going to treat it as the Z-scores becoming 100. So this right here will be your upper. So the lower is the Z-score 1.45. You press enter. I'm sorry, this was from the previous question. So 2.09, press enter, and your upper is 100. Again, I do give you the instructions on the test, but make sure that you have your own Dora moment. Press enter, 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 and 2.09 to 100, and my answer for the probability is 0.0183. So this is the answer for the probability of a value to be greater than 32.3. So we said that there were 4 parts. So the last part is asking for identify any unusual events. So events are considered unusual when they are, none of the events are unusual because the probability are greater than 0.05. So you have to look at the probabilities and see if they are lower than 0.05. So part D, we're going to check to see if A through C parts, if it has probabilities that are less than 0.05. So part A, the answer was 0.2743. That is not less than 0.05. 0.8529 is not less, but 0.018 is less than 0.05. So you're going to say event C. Event C is unusual because the probability is less than 0.05. Is unusual because 0.0183 is less than 0.05. Okay, so event C is unusual. That's it for this question. I apologize, it's 14 minutes, but it should be